What's going on, everyone? My name is Kyle, and welcome back to the channel. In today's video, we're going to recap the storms from March 3rd, 4th, and 5th, as well as look at the SPC updated Day 3 marginal risk and do a forecast discussion from 12Z to 12C. So let's go ahead and get started. Taking a look first here at the March 3rd, we can see that our primary focus region was in the Southern Plains, with 2 tornado reports, 62 wind reports, with 6 of those being 75 mile an hour, and 11 hail reports for a total of 75. Now going on to March 4th, we can see that the risk went to the southeast of the Great Plains as well as the Deep South, with 20 tornado reports, 320 wind reports, with 2 of those being 75 miles an hour, and 2 hail reports, with 1 of those being 2 inches in diameter or larger, for a total report of 342. Finally, going over March 5th, we can see that the threat shifted to the eastern seaboard, with 1 tornado report, 144 wind reports, with 1 of those reports of 75 miles an hour, for a total of 145 reports. Between these 3 days, there is a total 23 tornado reports, 541 wind reports, with 10 of those being 75 miles per hour, 13 hail reports, with 1 of those being 2 inches in diameter or larger, for a total amount of 577 reports. Now, let's go ahead and jump to the next risk of severe weather on Saturday. You can see that currently there's a marginal risk in the southeast Great Plains as well as the Deep South. With this information, we're going to go ahead and get into a forecast discussion from 12Z on Saturday to 12Z on Sunday, which is from 6 a.m. to 6 a.m. Central Standard Time. Let's go ahead and get into it. Let's go ahead and start with the 500 millibar chart. Here, we're looking for troughs, areas that is going to promote uplift. We can see at the 12Z or 6 a.m. Central Standard Time on Saturday, there's an upper level low located over northern New Mexico that is a positively tilted trough throughout that area. As time goes by, let's go ahead and put this into kind of a loop. And we could see that our upper level winds are definitely strengthening in the southeast part of the Great Plains, as well as advecting into the southeast United States by 12Z on that Sunday. This is going to be an enhance for uplift by even 12Z. The trough is going to be shifting more, but also keeping that same positive correlation, meaning that the forcing is going to be limited. Next, we'll take a look at the vorticity of the upper level trough. The vorticity is a term for the amount of spin inside the atmosphere. As you can see, currently at that 12Z time, there is a lot more promotion uplift throughout these different regions. Let's go ahead and put this into a loop and see how this develops. We can see that there is definitely going to be a lot more that's going to be advected into more of the southern plains and even some isolated areas that are going to be located more in the Deep South. Continuing on to this trough, we can see that the progression all the way up until 12Z the next day is going to favor the upper level trough being located over the Red River on the more eastern side of Oklahoma and Texas, but still keeping that same positively tilted trough that's going to limit the amount of forcing that is available. Next, we're going to go ahead and take a look at the 700 millibar chart. On this chart, we're looking for short waves. What are short waves? There are these little dips in the isobars that are going to enhance possible vertical motion. As you can see at 6 a.m. Central Standard Time, we have one that is in more central Texas, another one that's in western Texas to parts of Mexico, and then also one that is over Mexico. These short waves are always going to be dominated by the advection of relative vorticity, simply meaning they will follow the flow in more of an easterly direction. As we put this into a loop, we can see a couple different areas of shortwaves developing. By 21Z or 3 p.m. Central Standard Time, The shortwave is going to be advecting off a little bit more towards the east, which is going to be our dominant shortwave that we're going to have. And there also is another little subtle shortwave throughout this area. Even though the instability and the more of the risk region is more of the southerly direction, that means that even in more of Oklahoma and Arkansas, this could help promote vertical motion, not necessarily for severe weather, but definitely for enhanced rain potential and general thunderstorms. Now let's go ahead and continue on. As we go 3 hours forward into 6 p.m. Central Standard Time, we can see that we have a little subtle shortwave that's off in northeast Texas, as long as one that's kind of back here along this flow, and another one that's off in here. This one right here is going to be our main shortwave within the area that is under the risk. As we continue to put this into a loop, we can see that those mid-level winds start to increase due to the nighttime. By 12 p.m., you can see that there's going to be more of a stronger level winds being in there, but I believe this is going to be too far behind our surface low with our associated cold front and warm front, which is not going to have as good of an effect on this, which should limit the availability for definitely tornadic development and also severe potential after 6 p.m. Central Standard Time. Now we're going to go ahead and jump to the vertical velocity, but stay in the 700 millibar chart. This will help to visualize as far as the amount of uplift within those short waves. You can see, starting off about 6 a.m., there is definitely a lot of area that's going to help promote uplift. Let's go ahead and put this into a loop and see how it develops. So going into a loop, you can definitely see that there's a lot of vertical velocity, especially in Oklahoma. Given the limited instability, this could definitely enhance the probability for higher potential for heavier rain. As time goes by, we are at 21Z or 3 p.m. Central Standard Time. We can see that there is a wide screened range right throughout here, this area. And then if we keep going on from there, on to about the 0Z, when we think that shortwave is going to be about of its strongest at 6 p.m. Central Standard Time, we can see that there is definitely a lot of areas that are going to be affected. If I can circle everything, there we go. And with the primary of the region that we're going to be looking for severe weather is going to be more in that southern region and more of eastern Texas and the parts of Louisiana. Now let's go ahead and continue to put this into a loop. And over time, you can see there's definitely still a lot of vertical velocity in Oklahoma, Arkansas, and even parts of northern Mississippi, with an additional little bit of some vertical velocity happening around the Florida Panhandle. This area, around this time around midnight, is going to be our new focus time for severe weather. However, up here, we definitely have a chance for heavier rain and also general thunderstorms, given our PWatt values, or precipitable water. And finally, putting this into a more of a loop, we see by 9Z, and then finally by 12Z, or also known as 6 a.m. on Sunday, that we have a level of vertical velocity throughout eastern Oklahoma to Arkansas to Tennessee, Mississippi, but even down here and to Georgia, which I believe this area is going to be not necessarily severe, but a high probability for very heavy rain and potential flooding. Now, let's go ahead and jump to our 850 millibar chart, otherwise known as the lower level jet. At 6 a.m. Central Standard Time, you can see if these winds out of the Gulf, which is going to help pump moisture into our region that is under the risk for severe weather. Continuing on and putting this into a loop, we can see that much of these winds are definitely very weak, around 20 knots or so, which typically you want areas that are more around the 30 knots. For instance, there is a nice lower level jet that is over the Oklahoma region, but not enough instability to go along with it to promote that severe ability. But with that lower level jet, that can enhance the vertical motion in addition to the 700 millibar vertical velocity, enhancing the potential for heavy rain. Let's go ahead and continue on, and we'll go to 0Z when we're thinking about this setup at 6 p.m. Central Standard Time is going to be the highest. So as you can see here, we definitely have the winds that are going to be still affecting out of the Gulf into this area, with a little bit of a 30 knot lower level jet, which looks like this area might be our area of focus right around 6 p.m. Central Standard Time. Now let's go ahead and continue to put this into a loop. And we can see that there are little areas that are more developing, especially along the Florida Panhandle. But given the nature of the progression of the surface low, this may be too far behind to help increase the chances for severe weather. Now let's jump to the dew point temperatures at the 850 millibar level. We can see that our couple different areas are right throughout this general region, with even parts of northern Oklahoma at 10 degrees Celsius dew point. So I'm going to give you a little quick math lesson, or a quick estimation to get from Celsius to Fahrenheit. So all you got to do is, we have 10 degrees Celsius. So the easiest way to get approximation is you're going to double that. So times 2, which is going to be 20. And then you're going to add 30 to that, which is going to be equivalent to 50 degrees Fahrenheit, to show that we definitely have adequate moisture. In addition, if you just look at the colors, when you have the blue, that is definitely sufficient enough, because you want a lot of lower level moisture to help for storm development. As we continue on and put this into a loop, we can see that over time, our lower level moisture is evecting into our area, and by 0Z, when we think this is going to be the highest probability for severe weather, we have a lot of moisture to work with that's going to be just ahead of our surface low of the cold front and the warm front, with most likely, or most affected area, it's going to be in the triple point, otherwise known as the intersection where the cold front and the warm front come together at the surface low. Now for the last of our upper air models, we're going to take a look at the 250 millibar chart, since we are in spring. So as you see here at 12Z, we have that upper level low that's going to have that vertical tilt that's going to coincide with the 500 millibar chart. As we go through a loop over time, we can see that there's going to be more of an advection with that 0Z, thinking about the more of that northeast, eastern Texas, and the parts of Louisiana, with this jet streak right in that area. And then one last thing is, you could see that there is a little bit of divergence. It's very subtle, but it might be just enough for supercell possible potential. Now let's go ahead and jump to the surface. Starting off at 6 a.m. on Saturday, you can see that we have a broad surface low over central Texas. Now if we draw in our fronts, there's going to be a cold front that's going to be located right throughout that region. And then our warm front is going to be throughout here. In addition, if we take a look at our dew point deal, we can see that there's also going to be a dry line that is also going to be associated with this too as well. That might be developing more strongly over time. So let's go ahead and put this into a loop. And we'll stop here at 0Z, or 6 p.m. So now at this time, let's go ahead and draw in. So we have our surface low that's going to be located throughout that area. And then if we draw in our fronts, we're going to have more of the cold front. It's going to be more kind of a back throughout here. And then our warm front, which is going to be located more throughout that area. And then if we take another look at our dew point temperatures, we can see that there is a dry line that is advancing eastward with the progression of the system. Now with those factors in play, let's go ahead and take a look at the theta E. Theta E is just going to be a more simpler term for the amount of moisture and temperature. So right around the kind of that triple point looks to be some of our greatest gradients. That's going to be right ahead of that cold front, near the surface low, and also underneath the warm front. Now let's go ahead and look at our surface-based CAPE and the absolute vorticity. The absolute vorticity is going to be the sum of relative vorticity and planetary vorticity. Relative vorticity is going to be the amount of spin within the fluid and the air column, whereas the planetary vorticity is due to the Coriolis effect of the Earth. These two combined, we can see that there's a lot of vorticity throughout central Texas, but for instance, if you don't have CAPE or energy to work with, it doesn't mean anything. Now the 35 radians per second, we can actually convert that. So I'll show you quickly how to do that. So what we're going to do is we have to get that from radians into revolutions per second. So from what we know, 2 pi, if I can draw this in correctly, is going to be equivalent to 1 rotation. So we know pi is 3.14. So let's just round it down for an easy summation. So 2 times 3 is 6. So then all you have to do is you just take 35 divided by 6, which will give us an approximation of about 6. Anything that's going to be above 2 is going to be considered more strong. If it is between 1 and 2, it is moderate. And if it is 1 or lower, it is going to be considered weak. Now, let's go ahead and put this into a loop. As we can see time developing, there's going to be the energy that is going to be coming, building with the instability. And right around here, so a little over 16, right? So 16 divided by 6, so that's a little over 2. So that's still a good, strong area. And with our cape. Now, these are not the only 2 metrics. You've got to have as far as your lift, your moisture, wind shear. There's other things that go into it, but this could be a good correlator. And if you have those other ingredients, the surface vorticity and the cape could be good factors, more for severe potential and also tornadic development, but more with the 3 cape and the vorticity, in my personal opinion and findings. As we put this into a loop a little bit further, we can see that there's a little bit more instability building, and then we get to around that 0Z time. Like we were talking about before, and kind of the eastern northeast Texas looks to be as far as our main area of focus at 6 p.m. Central Standard Time. As we continue on with the loop, we can see that there is going to be some more instability that's going to be advecting off the Gulf. So then as that coincides, we can see that around 09Z, it definitely dwindles because it's just off the coast of the United States, but there still is considered at least enough strong, right? So 12 divided by 6 is 2, and our cape levels are a little bit lower, so the instability is not going to be nearly as high by the time we get to 12Z. So that's why I'm thinking about 6 p.m. is when this system is going to be the strongest. Now let's go ahead and take a look at our mixed layer cape and the mixed layer SYN combined. So as we go ahead in time, we can see that there's definitely an area that's being affected in more of the eastern part of Texas by 3 p.m. and then by 6 p.m. is a good consolidated amount. So between 3 to 6 definitely look very favorable for possible storms being nice and severe. In addition, you can see that there's a little bit of some instability that is coming off the coast that is just in the southern part of Louisiana. Hensing that around these times, I believe that around more of this area is going to be more of our area of focus for severe weather, or more on the western region of the marginal current risk that I believe is about into that area. So I believe is going to be more of the favorable target for more severe weather. Now let's take a look at our most unstable cape and our shear vectors. Most unstable cape can definitely be a key factor in determining more of a nocturnal threat if there is any. So as we go in time, we can see that 21Z, there's a good area too that coincides with the mean layer cape that gives us a higher amount of confidence between that eastern part of Texas and to Louisiana. We get into 0Z and there's a nice bright area, as you can see with the blue, that is in the eastern part of Texas. Now, if we take our fronts, let's go ahead and go back to the surface. Draw in our surface front. If it'll let me. There we go. So we got a little low. I'll put in the cold front. Alright, so like on the cold front was kind of coinciding in there. And then our warm front, which is right around that area. Now, if we go back, let's see. What you want is you want these shear vectors to be more perpendicular to this boundary and not going to be parallel. If it's perpendicular or orthogonal, it's going to increase the chance for supercell development. So that why this area definitely looks favorable for possible supercell development. Now that if we put this into a loop, we can see that 3 hours ahead at 9 p.m., it looks like in more southeast Louisiana into southern Mississippi becomes more favorable. And as time goes on until 12Z, all the way to the Florida Panhandle area. Now with the most unstable cape and the shear vectors in mind, let's go ahead and take a look at the supercell composite so we can put this into a physical evidence. As we continue throughout time, you definitely see that there's a higher chance for supercell development in eastern Texas and Louisiana. As we go on into about 0Z, we see this nice little favorable area around that triple point. Let's go ahead and give it a click. Now taking a look at that sounding, that is going to be in eastern part of Texas. We can see there is a little bit of some curvature in the lower levels and definitely some deep layer shear. So there definitely is as far as some directional shear. However, there's not a lot of speed shear, as you can tell right here in the lower to mid levels, until we get to our upper levels, which would limit the chance for tornadic development. However, we have a lot of area of 3 Cape of 234. That is very strong. So to give you the kind of a significance of showing that in, we have as far as the LCL, so that's going to be where the dew point and the temperature come together. So there definitely is going to be a fat area of Cape with our the effective storm relative helicity of 311 meters squared per second squared, which is above 300. So that does show as far as our promise. Our effective shear is 71, which coincides with definitely supercell development. In this region, though, however, it looks like our lapse rates in the 700 to 500 millibar region, to where it's going to be the most dynamic for knowing as far as the hail development, is only 6 degrees Celsius per kilometer, which is definitely going to limit, but there could be chance for a little bit of some hail reports. Finally, we can see our D-Cape is 928 joules per kilogram, which is going to be a moderate, and that is going to be enhanced by, as you can see, all this dry air up in here. That's going to be as far as with helping down with the flow. So around this time, this looks like to be more of a tornado and also a damaging wind risks around 6 p.m. Now we're going to take a look at our 0 to 1 kilometer storm relative helicity. For this area, you typically want values that is 200 meters squared per second squared or higher for higher potential for tornadic development. As you can see at 6 p.m. starting off, we have a decent amount of area, but that is going to increase as the time goes on. So let's go ahead and put this into a loop. And we can see as far as with those greens that it's getting more favorable at 3 p.m. And then we even got some yellows by 6 p.m. In addition, with these winds, you see how the winds are coming out of the east. And if you remember, we have the triple point. We had that low in there, and then we had our cold front and our warm front. So that is going to show that that's going to be a lot of inflow. And with having the shear vectors that's isolated the other way, this could definitely be an area, even though this looks really messy right now, for an enhanced supercell development and possibly a tornado. The last thing of the convective that we're going to go over is the mid-level lapse rates. Typically, you want values that is going to be 7 degrees Celsius per kilometer for increased chances of supercell development. However, you have to have other ingredients in place for this to become in handy. So as we go in time, and we'll go all the way to about that 0Z or 6 p.m., we can see that there's not a huge area, but there definitely is as far as a little area, tiny area, 7.2 degrees Celsius per kilometer, which is definitely sufficient enough, which is why I think possibly in this region, depending on how these models trend with the different updates of the runs, could be definitely our focus area at 6 p.m. But I still believe that looking at everything so far, around 3 p.m. to about 9 p.m. is going to be when this main area is going to be under the gun. Now for our precipitation, we're going to take 2 different looks at our simulated reflectivity and our total precipitation accumulation. Let's start with our simulated reflectivity. Starting off at 6 a.m., you can see that they are anticipating some showers and storms that are along the Red River. As time progresses, those showers definitely are still in play over much portions of Oklahoma and Arkansas. And if you remember, with that vertical velocity and an enhanced dew points at the 850 millibar level, that is going to enhance as far as the chance for rain and thunderstorms, but not severe, but could be some heavy rainfall. But also in addition, here we're at 0Z, right? When we're thinking it's going to be heavier, it looks like this little area in here could be possible supercells with some more coming off of kind of the coast. And these winds are going to help drive it onto the coast as our time progresses. As we continue on and keep putting this into a loop, We can see that that's the play. There you go, by 06Z, about 12 p.m. It looks like it's going to be more of the Florida Panhandle and southern portions of Alabama that are going to be more under the gun. And then we'll continue on from there and go up to 12Z for 6 a.m. Central Standard Time. And we could see that in here, I believe this would be 7 a.m. Eastern Standard Time, that there is going to be probably some showers and thunderstorms. However, at this time, I would believe it would be limited in the amount of severe weather. All right, so the last thing we're going to take a look at is the total precipitation accumulation. This will give us an idea on how much rainfall is expected and where flooding risk could be the greatest. As we put this into a loop from 6 a.m. on Saturday, we can see that there is a good amount of rainfall happening with an increased vertical velocity in parts of Oklahoma and Texas, as well as the southeast. As we continue on, we can see by 12Z when that risk for severe weather as far as the day 3 outlook ends, our main risk of flooding is going to be throughout much parts of Oklahoma. Now, if we continue and put this into a loop a little bit further past that, we can see, if you remember, that vertical velocity that was increasing in southern parts of Georgia to where there definitely could be concerns for flooding in the Florida Panhandle and parts of Georgia. So let's go ahead and wrap up this video. So our main area of threat is going to be between 3 p.m. to 9 p.m. Central Standard Time in parts of eastern Texas to Louisiana. Right now, the SPC has this listed as a marginal risk. However, I would not be shocked if they increase this to a slight risk. However, that positively tilted trough is going to weaken the forcing, but there definitely is area for supercellular development, especially with the peak, in my opinion, of the current model at 6 p.m. Central Standard Time. So make sure that you have some kind of updates or something to keep you weather aware. If you enjoyed this video, I'd greatly appreciate it if you could help support me by subscribing, liking this video, and sharing this video with anyone that might need to stay weather aware. Thank you for watching, and until next time,